Yep. Good evening, everyone. So, yesterday you designed that relationships, huh? Huh? Right? We have a lab group, huh? You uploaded, huh? So, have you created relationship example? I asked you to try, huh? Where you prepared soft copy, huh? Or in book, huh? Anybody done soft copy of that? Yesterday I asked you to try relationships, na? Between the modules. Anybody done? Soft copy, anybody done? No? At least in paper you written? Anybody? Huh? User ID foreign key cart. Uh, no need to draw diagram, but primary key, foreign key configuration you need to do. It's okay. I will show. I will add one document. You check that. Huh? Right. Fine. Anyone else done? No. Online people also nobody done. Okay, so I will just give you the point here. In the yesterday's, I asked you to just create a relationship, physical model, logical model you need to create. And according to the logical model, you have to design. So, design work you do. Design work means creating tables and all, you practice them. Here I will just show you the relationship also. Physical model have all this. Okay. So here we need, yeah, this is the data we are having. In this data, I given the table and fields. I asked you to just try the relationships. See, project means majority work you have to do. I will just guide you in some points. Rest of everything you need to do. Okay. Just a small rough relationship diagram I will means just relationship we will see here. So in logical, we will have the table and fields. This is the logical model. I asked you to try this. Okay. In logical model, first, what is the table? TBL users. In TBL users, user ID, it is PK, primary key, user name. another one password, another email address. We don't need to mention any data types. In logical model, we just mention the table and relation. Table and relation. Okay. Next. So another one is what? TBL categories is there na? Category will have a category ID. Category ID is primary key and name a category name. Next, TBL what? Products. In the products, we will have a product ID. Product ID is a primary key. So it will have name, price, image, what else? Quantity, rating, category ID. This is foreign key. Understood? That is the foreign key. This foreign key reference comes from TBL categories. The reference will come from TBL categories that we will design. Next, another one, TBL cart. In that we have an cart ID. Cart ID is primary key. It is primary key. Another one, user ID. It is an foreign key. Another product ID. That is also an foreign key. We can have multiple foreign keys. Right? So next, TBL shipping. Okay, it will have vendor ID. This is primary key. What else? Name. Another address. Another category ID. This is an foreign key. Anything else? TBL admin. We have TBL admin. In that what? Admin ID. That is primary key. What else? Name. Another one, password. These are the details. Anything else? So these are the basic details that we have. This is the outline of a logical model, how we configure. Now, how to build relationships, we need to learn. I will just give multiple foreign keys, how we can add multiple foreign keys. Actually, so how we can define multiple foreign keys here is, let's go to MySQL. Project we will do later. I'm just explaining the scenario for project. That means to understand relationship, I'm just giving a point here. So designing project, database and all, we are going to see in next levels. Okay, first, how to configure relationship inside the tables. Let's see. So I will close all the queries. So we don't need all this. Okay. So I'll just clean up everything. Tables also I will delete. Drop table. Okay. So we have a sample DB and everything is empty. I'm not creating all of them. You try them. I will just give one small point here. For example, here we have multiple. Here we are having multiple. TBL cart have cart ID, user ID, product ID. For example, we are having three tables. So create table TBL products is one table. Roughly, I will create product ID. So we have tiny int and it is primary key. Primary key. Okay. Next, we have a name varchar some 20. That's fine. As of now, just only these I'm giving. It will have a, what is it? Category ID. Acha, this we will use later. Huh? Okay. Now I will run this. The products table is generated here. Okay, TBL products is generated here. We will create another table. The table is, for this we need a user. TBL users. I will just give user ID and I will just give varchar 20. Okay, and username. We will have a user ID and username. Okay, this is another table. We have two tables created, TBL products and TBL users. One more we need cart, TBL cart. Okay. So we will create here TBL cart. Okay. What we need? We need cart ID. So it is a tiny integer and it is what? Primary key. Primary key we are defining. Next. So here we need to create two foreign keys. First, to create foreign keys, first those fields must be designed. First, you have to design the fields, then we have to mention them as foreign keys. What are the fields required? So one is user ID. It's varchar, how much? 20. Right? Another one, what is it? Product ID. So that is what? Tiny int. That is tiny int. Now here we want those two as foreign keys. User ID is a foreign key, but it comes from users table. Product ID is a foreign key, comes from products table. Then how? How to configure foreign key? Directly we can write foreign key. But in future, if you want to modify those foreign keys, then it is always better to design as constants. Create constants for future. So how you define? We have to write, what is it? Constant. And what is the constant? Constant name. We have to define the constant name FK. This is user. Constant name is foreign key user. So what it should use? Foreign key. Foreign key. And foreign key from which field it should use as foreign key? User ID, it should use as foreign key. References. References is coming from which table? Reference is coming from where? TBL users. It is coming from TBL users. In TBL users, which one? User ID. That is how we need to configure. So that is how we need to write the foreign key. Suppose I need to put another foreign key. That means what we have to define another foreign key. How you write another foreign key. Suppose I'm using FK. This is related to which one? Product. And it should use foreign key. Foreign key. Yeah, foreign key. What is the foreign key field? Product ID. What is the references? References come from where? TBL products. In TBL products, what is it? Product ID. Product ID is the key. Product ID. We need to configure that. That is the constraint we need to define. So this is one. Another one is another constraint. Constraint. So we need to define these two constraint. One foreign key, user ID, another foreign key is product. Multiple foreign keys can be defined, but you have to write like this. Now I will run this. So we need to create a table. It is created. You refresh. You see a TBL cart is created. In this TBL cart, you can see that the columns have cart ID, user ID, and all. In the foreign keys, you will find here two foreign keys are there. One product related foreign key, another one is user. Of course, on update, on delete, we haven't given. By default, it will be what? Restrict. But you can define multiple foreign keys. How do we configure single or multiple foreign keys? This is the way we can define that. So I will give a syntax here. So this is a simple syntax configuring multiple foreign keys. This is multiple foreign keys, how we configure. Just for clarity's sake, I will give like this. Now you need to design all the tables like this with relationship and all. But just for practice, when we are doing the project, we will do it manually. All the tables we will do. I explained the project just for understanding relationship, how the relationship is designed. So the foreign key, constraints, how to add them. This is designing a table and configuring relationship, how we can design table and relationship. So finally, oh, this is, yeah, finally, what you learned here is related to table, creating table, and you learned about MySQL types, and you learned about constraints, different types of constraints, and relationship, how to design relationship between tables. So in the relationships, as I told you, while creating project, we will design one to one, one to many, many to many, like that. Example I already told you. One to many means one to one is, so every user will have one shopping cart, right? That means every user can have one shopping cart. So, and every shopping cart belongs to one user. One shopping cart cannot be used for multiple users. This type of relation is what? One to one. In this example, what is one to one relation is every user will have one shopping cart and every shopping cart can be used only for one user. That is one to one relation. So I will give here the relationship. In shop, iShop, relationships in iShop here. First one is one to one. So every user can have one shopping cart. Every user can have one shopping cart. And every shopping cart can be only for one user. That is one to one. Every user can have one shopping cart and every shopping cart can be only for one user. Next, one to many. One to many. So one to many is where you can use this in this application. How? One to many. That means one category can have many products. Am I right? One category can have many products, but many products belong to one category. A product belong to only one category. A product doesn't belong to one category. A product can belong to multiple categories. We can have like that if it is complex data. That means one product can be in multiple categories. For example, can we have one subject in many courses? Yes, we can have same subject in many courses. Similarly, a product can be in multiple categories also. But it depends whether you want like that or not. That means you want a product in only one category, then you can maintain the relation one to many, right? Otherwise, you have to maintain many to many, right? I will show the point here. One to many where you can use is here we can use vendor. Here we can use shipping. Vendor is there na? Every vendor, every vendor can supply, every vendor can supply multiple categories of products. Every vendor can supply multiple categories of products. That means, for example, Reliance Digital, it is one vendor, right? It can supply multiple categories, televisions, mobiles, different categories of products they can supply. That means it depends. That is completely on project requirement. So one to many in our project where you can use one to many is nothing but we can define. So like one vendor. So one vendor can supply products of many categories, multiple categories. That depends how you want to design. And not only that, here one category can have multiple products. Under one category, you can have multiple products. But it can be reversed also. What is it? Many to one. What is many to one? Many products belong to one category. Na? Reverse way relationship also configured. That means many products can refer to one category. Not only that, many products, many categories can refer to one vendor. One vendor can have many categories. Reverse way also can be there. But remember that completely on our requirement, whether you want like that or not, that depends. One vendor. So next, what is many to many? If you want many products can map to many categories. Many products can map to many categories. If you want, you can define like that. We can take separate examples, but I am taking just iShop example, how we can design. That means one product you can find in mobiles category, the same product you can find in electronics category, like that. So many to many is nothing but many products can be in many categories. Many products can be in many categories. It's not like one product will be in one category. Right. Another, not only that, many vendors can refer to many categories also. That's also can be a relationship. Many vendors can supply many categories. These are all the relationships we will use in our project. So no need to design them now. Later in project we will do. Just I am giving a complete idea about how we can do, how we can refer. Okay. So this is the concept of configuring relationships in our project. So you need to just learn how to create, practically what you practice is how to create a table with all constants, different types of constants, how to design them. Okay. Next, we will work with this project in next level. Now, next we need to understand after creating tables. This all comes under tables. After creating tables, now we need to understand how do we insert, query, update, delete all these operations. Next, important, inserting data into tables. Inserting data into tables. After creating table, defining relationships and all, how do we insert data into table? So SQL provides a data manipulation command. Command insert. It provides a data manipulation command insert. So which is used to insert data. Insert data into a table. Insert data into a table. SQL provides data manipulation language command called insert. By using that, we can insert. But what are the rules syntactically? Insert into table name. So fields, values, like this, we need to define. Insert into table name, field name, and values. So field name refers to the column header in table. Value must match exactly with the field data type. Value should match exactly with field data type. So number numeric values are directly defined. Numeric values are directly defined. So that means 20, 30, like that, directly defined. 20, 30. So some values are directly defined. Values are directly defined. String values are defined using single quote. We have to define using single quote. Some John, like that, we need to define using single quote. String values are defined using single quote. Numeric types are directly defined. String types are defined in single quote. Date values are defined using single quote. So, but must use the format year, month, day. It must use the format year, month, day. Date values are defined using single quote, same like string. But it must use the format of year, month, day. So that is a simple concept of inserting data into table. You can insert, so here another point, you can insert multiple records by using comma delimiter. You can insert multiple records using comma delimiter. We have to use a comma separator. So creating table and inserting data into table. That means multiple means what? Syntactically we have insert, insert, insert into table, field 1, field 2, values, val 1, val 2, comma, again val 1 and val 2. Like this, we can have multiple. That means first val 1, val 2 are first record, val 2, these are second record. You can insert multiple records. That's a simple thing. So you want to add data into tables, then we have to follow this. Roughly, I will show you the concept here. I will, yeah, I will go to the users. Oh, in the users, what we have? User ID and username. Okay. But both are actually string type. So what we have to do, insert into TBL users. insert into TBL users. What are the fields? So user ID, another one is user name. So what are the values? Values are, we need to define the values. Both are string type. One is username John underscore NIT and user ID, that is username is John. Like this, we need to configure the data. That is one record. If you want multiple record, again, we need to SAM and we need some Samson like this. We have multiple records like this. And we insert those two records are added. Now you right click, select rows, you see those two details are there. That means we are adding data directly into the table by using which one? By using insert. Insert. It depends on what type of data they are expecting. If it is date, means you need to create such table also. So for example, in this products, I have only ID and name. So I will drop this here. I will add here. Don't worry. I'm just for understanding sake, I'm using visual. Later we will learn commands. Just I'm modifying. This is MFD. MFD is manufactured. Manufactured is a date. So it is a date. Okay. And I apply and apply. Okay, close. So this is usually one table created and table is products. In that there is a manufactured also. Now how to insert data into that? I will copy one example here. This is one example for users. Okay, let's put another also, then we will see. How to add data? We have insert into table. TBL what? Products. Okay, field. What is it? Product ID. And remember, if it is auto incremented, it is default, they will automatically work. That means if you don't mention value for them, automatically the value is taken. And already we learned default value can be replaced. Na? We can replace the default value. Product ID, another one is name, another one is manufactured. What are the values? Values ID is 1 because number type are directly defined. Name is string and date is mentioned in year 2026 01 month and day 10. That's how we need to define the date value. So date must be in year month day format. It must be in year month day. So I will copy, I will run this. Record is inserted. Now select and see here and you can see the date is added correctly. If there is any problem in the data type that you are sending, then record will not be inserted. Record in will not be inserted. So if you are sending, if you are sending date number string, this is the format you need to send. Understood? The just example I am giving. So inserting data into table, that is done by using which one? Insert. Insert. So this is a simple one, how we can insert data into table, right? Next important, you need to know how do we select. Querying data from table. How we can query data from table. So remember, when you are inserting, sometimes if you have a doubt like how do we insert into a foreign key field, same foreign key field, same its data type, what it is expecting, we have to pass the same data into it. There is no special for that. So how we can query data from table? How do we query data from table? So for that, we have a select query. SQL provides select command. It provides select command to query and read data from a table. SQL provides select command to query and read data from a table. Select can use wildcard or field names to access data from table. Select can actually use wildcard or field names to access data from table. But important is actually syntactically select star from table name. Select star from table name. And important here is select field name, field 1, field 2, like this, and from table name. So select star from table, field 1, field 2 from table directly. Here, very important is one small note you need to know is the wildcard asterisk is not recommended at production level. It is not recommended at production level. Generally, while using, we use star, but it is not recommended. In future also, when we are writing server-side programming logic, when we write server-side programs and logics, we don't recommend star. In interviews, sometimes they ask a question like, I am designing one app. In that app, I have to bring and display details about millions of products, hundreds, thousands of people data is present. I want to show that information. Can you please give me suggestion how I can improve the performance of application because every time I have to deal with millions of data. That means we will give lot of suggestions. I will explain while learning programming server side, we will do that. One suggestion we give is better not to use star in query. That is the first suggestion we give to the developers, that never use stars in queries. Why? Because what is star? Star is a search pattern. Star is a search pattern. It searches for all fields and it will return all the fields. Star refers to all fields. Searching and reading is again an extra work. If you directly mention field name, it will avoid searching. It will directly point to the field. You may ask like, I have 500 fields, what to do? Write all 500 fields, right? You have to write all 500 fields, but don't write star. That means people ask like, I have 500 fields, what to do? What to do? You have to write all 500. I have 200 fields. Write all 200 fields, right? But if you use star, then it will decrease the performance. It will delay the process. So the first suggestion we give to developer is, especially while writing database queries, don't use stars in queries. So it is used while designing and all, but in reality it is not recommended. So how to select, how we can access here, two options are there. What to do? So we need to put here select star from table name. Table name is some TBL users. Then it is going to execute and get the user's data. But it is recommended always to define the field names, user ID and what? User name. User ID, username from TBL users. This is always recommended. That is good and it is fast, right? You cannot say that I have 500 fields, what to do? What to do? You have to write all 500. That means better not to use asterisks. But you have that facility, you should know that. Next important is in the query, we will have actually select query can have the following. Select query can have the following: wildcard, field name, alias names, and expression. Select query can have these following: wildcard, field name, alias name, and expression. So it can have wildcard, that is asterisk, field name is field name, alias names, and expressions also we can have. Alias name is nothing but, so syntactically we define select field name, field 1 as alias name from table. Field 1 as alias from table. So what is this alias is nothing but alias is a friendly reference name given for field to display in query result. Because actually, when you create the fields, field names cannot be friendly. User friendly names cannot be there because you cannot have spaces. You cannot have friendly names. You have to follow tradition rules. But We can display friendly names while showing in the query. So how we can set the friendly names? So for example, I am selecting here. Select, suppose uh, product ID. Product ID, I cannot use product space ID. Why? Because that is product ID, that is the column name you have to use in the same way. You cannot have a friendly name. So I will use as I will give a name as product code. So product ID I will display as product code. So and after that name as product name, product name from where TBL products. Then in the query it will show that. That means in the query it is going to display a different name for the fields. Generally the field names are used exactly what they are. We can put a friendly name by using an alias. So alias is used to set a friendly name. Example, here we have select, suppose product ID as product code and name as product name from TBL products. We can put a friendly name. If you don't define the alias names, the same field names are displayed in the query result. So you can have a wildcard, you can have field name, you can have alias, you can have expression also. You can have directly an expression in the select query. Usually, how the expression can be. For example, see here, okay, let's do one thing. I will add product. Some more details I need to add. In the product table, I am adding price. So price is a decimal. So some 8 and 2. 8 and 2 I am using. Another quantity. Quantity is an integer. Fine. I am adding price and quantity into the table. Then obviously when we select products, the price I will enter as some 45,000 and quantity is 2. Mobile and some price 2026. So 0102. Some price is there and quantity is 2. Like this we are adding. And apply, we are adding multiple records updated. Okay. Now what we are doing here, select, we need to select, yeah. Let's write the query. So roughly select, what is it? The name as product name. Am I right? Okay. After that, we have price. Same price will be price only. QTY. So QTY as quantity. I want to display the QTY as quantity because we have quantity na. Yeah. as quantity. And after that, so we have quantity into price. Quantity into price. That means we are defining quantity into price as total. As total. That means your select query can have field name, can have alias name, can have an expression. Usually, expression can be used to perform various operations on the fields. Later, I will tell you what expressions we can use. String expression, number expression. I will show different expression. So you can see here, this is going to execute and show the result for us. Oh, some problem? Uh, name from is missing as total from is missing na from which one TBL products. Yeah, I will run this and see now, and it will show the result like this. It will show the result in this way. That means the field name is product name, second field name is price, third name is quantity, and the fourth one is total. It will have an expression also. That means the queries can have field name, wildcard, expression, and alias. They can have alias, right? So, how the expression can be defined? So, syntax here. Syntax here is select field as alias and expression from as again alias from table name. So here one important note, expression refers to operations on data fields. Expression refers to operations on data fields. Operation on data fields. Actually, lot of operators are there. Initially, I will give a basic. So expression can use various operators. Numeric, string, etc. So example, select name as product name, quantity as quantity, as total from products. So can we access fields from multiple tables and show in one location? That is possible with views. Views. By using views, we can manage that. So first, now in this, how the queries are used, how we can find exactly filtering, sorting, searching, and other queries. So now we can handle the filtering, searching, sorting, and aggregation by using one more command is used here. And what is that command is where, right? So while working with select query, we need to filter, sort, or do some aggregations. Then we need some more operators. And those operators we have to learn. That we'll see tomorrow. Right, in tomorrow's session, we will discuss about all the operators, how to use different operators in queries, aggregation operators and other operators, how to use them. Then we can learn updating, deleting, altering, and all these options. Tomorrow we will continue with this. Okay, right.